Hello everyone, this is the first lesson recording for IM2, January 7th, 2021. What are we doing today? We are going to be reviewing factoring by grouping, and we're also going to be learning another method, the area model method. And that's an alternative method to the grouping method for those of you who are struggling with that. All right, so as part of your warm-up, I would like you to try to factor these two quadratic expressions by grouping. So please pause the video and factor them now. And here are the steps that are laid out for you again as a reminder. So the first thing I need to do is solve the diamond. To set it up, I need to set up the top number and the bottom number. The top number is multiplying the coefficient of x squared and the constant. So 8 times negative 15. That's going to be 120. Okay, and that's going to be negative because 8 times negative 15 is 120, and then positive 14 is at the bottom. Now we're looking for two factors of negative 120. That means one's going to be positive, one's going to be negative. We don't know which one is going to be which. Okay, so in this case, we are looking for difference of the two numbers. Okay, so the difference of the two number must be 14. Okay, so let's go through it systematically. Okay, so if I have 1 times 120, the difference will be 119. That's way too big. What about 2 times 60? The difference is 58. That's still too big. 3 times 40, difference will be 36. We're getting smaller, but we still have a long way to go. 4 times 30 would be another one. 4 times 30. You can certainly use a calculator. What about 5? 5 times 14. No, 24. 5 times 24 will be 120, and the difference is 19. So we are getting smaller. Okay, what about 6 times 20? And that's 14. Okay, so at this point we found our 14. The difference is 14. Now we need to decide which is the positive number, which is the negative number. We want the sum to be positive. That means the bigger number has to be positive. So it's going to be the bigger number. 20 is going to be positive. That makes the smaller number 6 to be negative, so that when you add 20 minus 6, you end up with positive. So I have found my two numbers. That's going to be negative 6 and 20, positive 20. Now I break the middle term, the 14x, as negative 6x and 20x. So I rewrite that. 8x squared plus 14, sorry, so minus 6x. And then to that, we are going to add 20x, and then finally minus 15 from the original expression. The only difference is that we split the 14x, the middle term, as negative 6x and plus 20x. So then once we have done that, we can put our parentheses. The first two terms get a parenthesis, and the last two terms get a parenthesis. In this case, since it is since the 20x is plus, I don't need the extra space. I just need to put the parenthesis right there. So I end up with one parenthesis plus another parenthesis. Now I look at the first parenthesis and look for the GCF. What the 8 and 6, they are both even numbers. That means I know that I can take at least 2 out. And of the variables, I have x squared and x, so I can take out x. So 2x times what is 8x squared? That's going to be 4x. 2x times what is negative 6x? That's going to be minus 3. Okay, plus, what about the second number? 20x minus 15. Okay, there are no variable in the second term, so there are no common factor variable, but of the numbers 20 and 15, the common factor would biggest common factor would be 5, which leaves me with 5 times what is 20x? That's going to be 4x. 5 times what is negative 15? Negative 3. And now notice that we have 4x minus 3 here and 4x minus 3. That is a common factor to both the first half of the expression and the second half of the expression. So I am going to take that out as my common factor, which leaves me with this 2x here. So that's my second expression, and plus 5 here, plus 5. And this is my final answer. And of course, you should multiply this back out using FOIL to make sure that you end up with the original 8x squared plus 14x minus 15. Okay, so that's the first problem. For the second problem, I am going to show you my work on the next slide. Okay, so 10x squared minus 33x minus 54. Again, I need to put my draw my x and place set the diamond problem up. 10 times negative 54 is negative 540, and the middle term is negative 33x. So the coefficient is negative 33, so it goes here. Now we're looking for the solution to the diamond. Okay, so we're looking for factors of negative 540, and it's a big number, so we are going to have a lot. And since we are looking at either it's going to be one's going to be positive, one's going to be negative. So instead of just, well, you could say that the bigger number has to be negative because we want to end up with negative, and that's what I did here. But, or you could just look at for the difference between the two numbers. Okay, so 1 and 540, 2 and 270, you look for the difference, and we end up with 12 and negative 45 as the solution. Okay. Now, I want you to think about this, all right? Doesn't matter whether I put, matter which way I arrange the middle term. Doesn't matter whether I put 10x squared plus 12x minus 45x minus 54 as a split, or, reverse the negative 45x and 12x. Doesn't matter. Is it going to make any difference to the final answer? No, it actually doesn't. And you can see the work I've done here and compare the two different method or two different um, work. And still, once you look for the GCF, the difference is going to be which is the factor that you're going to be coming out with first. Okay, so then in this case, you got 5x plus 6, 5x plus 6 as the common factor here. In this case, 2x minus 9, 2x minus 9 as the common factor. But the other factor comes out when you look at for what the 2x minus 9 was being multiplied to. So either way, it does not matter. That's something I do want you to notice. Okay, so I do want to look for some patterns that will be helpful for us to notice. So when you're factoring 6x squared plus 17x plus 5, how do we figure out 17x should be split as 15x plus 2x? Well, we split up as 15x plus 2x because we solved the diamond problem. Okay, and that's what we started off with. What if we just randomly split it as some other number, other combination? 17x could be split as 10x plus 7x, or maybe even 11x plus 6x, right? So, I mean, what happens if we do that? What happens if we did not solve the diamond problem properly, or if we just came up with just some random split? Well, in this case, this is the one where we did it properly, and you do get the right answer. Okay. All right, so in this case, when we did it properly, split it up as 15x and 2x. You look for the GCF of the first parenthesis. You get 3x, and 2x plus 5 is the inside the parenthesis. What about 2x plus 5 here? Well, we don't have any factor to come out, pull out. Then in that case, remember what is the number that we can put in here that can, oh, that does not change the value? It's 1. It's not 0. It does not just go away. There is a 1 being multiplied here. So this becomes 3x plus 1, and the plus 1 comes here. And then 2x plus 5 is the common factor here. Now, what if we just randomly picked some different split? Then again, we put the parentheses. But when you look for the GCF, you take out the GCF. Notice that 3x plus 5, 7x plus 5 here, they're not the same. That's how you know that you've made some mistake somewhere. Okay, if you're using the grouping method, if you solve the diamond problem properly and you factor it out properly, you should always have a common factor being multiplied to both the first half of the expression or first parenthesis and the second half of the expression. All right. So likewise for this, if you just randomly split 17x as 11x and 6x without solving the diamond, then it's also not going to work out. Okay. So 6x plus 11 is the first factor, and 6x plus 5, they are close, but they're not exactly the same. And close enough is not good enough. So in this case, there's no GCF to factor out. So this is not going to work. So that's how you know that if you made a mistake. Okay, so your GCF should factor out to be identical, just like 2x plus 5 here and 2x plus 5 here. Okay, what is the pattern of product of the first and the last and the two middle terms? Okay, so once we've done the split for the grouping method, something else I would like you to notice is 3x squared and 8. If I multiply this, I get 24x squared. If I multiply the two middle terms that I split, 6x and 4x, I would get the same number. Okay, because 6 times 4 is 24, and x times x is x squared, so 6x, 24x squared. And it's the same thing with the other problems that we did last lesson. Okay, the multiplying the first term and the last term and the two middle terms should always be equal to each other if you're splitting the diamond of the solution, the middle term properly. Okay, so that's one way to make sure that you've solved your diamond properly. Okay, great. So then this is an additional resource. This is just basically the grouping method somebody else made a YouTube of that. So please watch it if you're still struggling with the grouping method. All right, so I'm going to introduce yet another method. This is an alternative method to grouping method. For those of you who found the grouping method to be a little bit more tricky, who maybe perhaps would like more visual representation, this might work better for you. Okay, but I did choose the grouping method first because to me it makes more sense, as well as it's a little bit more algebraic that you're going to be able to do more readily. Drawing the area model, it takes a little bit longer, and it's a little bit more tedious. And if the area model makes sense to you, go for it, okay? But I found the grouping method a little bit easier for me. But to get that started, do we remember how to multiply using area model? If I have the one of the length as 4x plus 3 and one of the width as 3x plus 2, how do I multiply? I just find the two 4x times 3x and you get 12x squared, and then 3 times 3x and I get 9x here, and 4 times 2 get 8x, and then 3 times 2 I get 6. All right, and so this tells me that 4x plus 3 multiplied by 3x plus 2 is 12x squared, plus then I combine the like term 9x and 8x, which gives me 17x, and then plus 6. And that's how you would do it. I'm going to continue on the next lesson recording.